Hello guys, my name is Bino, and in this video we'll be focusing on question 3 from the April 1st 2020 N4 mathematics question paper. Question 3.1 states that we must use the chain rule to differentiate the following. So we have to let u equal tan x, and we differentiate the u with respect to x. So du over dx will be, so the derivative of the tan x is equal to sec squared x, also available on the formula sheet. And since we say that u is equals to tan x, so where there is tan x, we will substitute u. So we'll have y is equals to the square root of u, which we can write as u to the power 1 over 2. From here we differentiate this y with respect to u. So the derivative of that u to the power 1 over 2 will be u to the power 1 over 2 multiplied by 1 over 2 minus 1, and this will be equals to 1 over 2 multiplied by u to the power negative 1 over 2, which we can also write as 1 over 2 multiplied by u to the power 1 over 2. So we take this u to the power negative 1 over 2 to our denominator. Is going to change sign from the exponent, is going to change sign from negative 1 to positive 1 over 2. So from here we have our dy over du is equals to 1 over 2 multiply, and this u to the power 1 over 2, we can express it as a square root of u, and in the place of this u, let's substitute back the tan x, because we say that u is equals to tan x. To find dy over dx, we simply have to multiply the du over dx and the dy over du. So we multiply the sec squared x, the du over dx, with this dy over du, which is equals to 1 over 2 multiplied by the square root of tan x. So this will be equals to, so this sec squared x multiplied by that one will be sec squared x over 2 times the square root of tan x. Question 3.2, we have to differentiate the following into y is equals to 2 to the power x plus 1 over 2 ln x plus 1 over 2 e to the power x plus 16. So we know that when we have y is equals to e to the power x, when we differentiate this with respect to x, we get ln of e multiplied by e to the power x, but ln e is equals to 1, so this will just be equals to e to the power x. So in this case we have dy over dx, so we ln the 2, just like here we ln the e, but the ln of e was 1, so we ln the 2, so ln 2 multiplied by the 2 to the power x plus 1 over 2. The derivative of ln x is 1 over x plus 1 over 2 multiplied by ln e, which is equals to 1 multiplied by the e to the power x, and the derivative of 6t is equals to 6. So our dy over dx will be equals to ln of 2 multiplied by 2 to the power x plus 1 over 2x plus 1 multiplied by that e to the power x will be e to the power x, and 2 multiplied by that 1 will be 2 plus 6. Question 3.3, we have to determine the following limit, the limit of x squared minus 4 as x minus 2 approaches x is equals to 2. So we can see that immediately when we substitute this 2 here, this will be 2 minus 2, and this will be 0, and we can't divide by 0, but we can see that that's the difference of 2 squared. So if we had a squared minus b squared, this will be a minus b into a plus b. So we can rewrite this limit as limit of x squared minus 4 squared, 2 squared, which is equals to 4 over x minus 2 as x approaches 2. So we can solve this limit as limit of, so the x squared minus 2 squared, because there is a negative in front of it and we also have the squares, we can write this as x minus 2, x plus 2, all over the x minus 2 as x approaches 2. So that x minus 2 with that x minus 2 will cancel out each other, and we'll be left with limit of x plus 2 as x approaches 2. So in the place of this x, we substitute the 2, and when we substitute, we drop the lim. So we'll have 2 plus 2, which is equals to 4. So the limit of x squared minus 4 over x minus 2 as x approaches 2 is equals to 4. Question 3.4 states that differentiate the following by the use of first principle. So you guys will be differentiating y is equals to negative x cubed plus 5x from first principle, and the answer will be equals to y is equals to negative 3x squared plus 5. So question 3.5, the displacement of an object is represented by s is equals to the integral of the square root of t minus 5 all squared dt. Determine the value of s. So we have to solve this integral. So we have s is equals to the integral of 1, the integral from 1 to 4 of the square root of t minus 5, that's squared. So let's expand the square root of t minus 5 dt. So before we can integrate, let's first simplify the factorization. So the square root of t multiplied by the square root of t will be equals to t, the square root of t 5, the square root of t, negative 5 multiplied by the square root of t will also be equals to negative 5, the square root of t, negative 5 multiplied by negative 5 will be equals to positive 25 dt. So from here we have t minus negative 5, the square root of t minus 5, the square root of t will be equals to negative 10, the square root of t plus the 25 dt. So let's write the square root of t as t squared, to 1 over t, I meant t is plus 25 dt. So s will be equals to, so we integrate, so the integral of t will be equals to t squared over 2, and the integral of t raised to the power 1 over 2 will be equals to t raised to the power 3 over 2 multiplied by 2 over 3. The integral of 25 will be equals to 25t, and this is from 1 to 4. From here, let's substitute our boundaries. So where there is t, we first start with that 4, the bigger number. So we'll have 4 squared over 2 minus 10 multiplied by 2 over 3 into 4 raised to the power 3 over 2 plus 25 multiplied by 4 minus, so where there is t now we substitute the 1, so this will be 1 squared over 2, which will be 1 over 2, minus 10 multiplied by 2 over 3, and the 1 will be raised to the power 3 over 2, which will just be 1, plus 25 multiplied by 1, which will be 25. From here, let's use our calculator. 4 squared over 2 minus 10 multiplied by 2 over 3 multiplied by 4 raised to the power 3 over 2 plus 25 multiplied by 4 minus into parentheses 1 over 2 minus 10 multiplied by 2 over 3 plus 25. And our answer will be equals to 35,833. They said that this is a displacement, and displacement is the same as distance. So, and distance is measured in meters or centimeters. So in this case, you're not given any SI unit, so we'll just use unit. So S will be equals to 35,833 units. Question 3.6, we have to simplify the integral of sec of 4 sec to the power 4 theta minus 9 all divided by 2 sec squared theta plus 3 d theta. And there is no formula that or method that we can use to evaluate this integral, so we have to simplify. So we can see that we can channel the numerator to be a difference of 2 squared. So if we had a squared minus b squared, this will be equal to a minus b into a plus b. So let's channel the numerator. So this is already guiding us that we have to channel this so that it can be somewhere similar to that. So we can write that 4 as 2 squared, and we can write that sec to the power 4 theta as sec squared theta squared. So sec squared theta squared is just the same as sec to the power 4 theta minus the 9 we can write it as 3 squared over 2 sec squared theta plus 3 d theta. And from here we can, because you are multiplying and the exponents are the same, we can write this as 2 sec squared theta all raised to the power 2. So this 2 multiply, so this square is going to affect this 2 and this sec squared theta minus 3 squared over 2 sec squared theta plus 3 d theta. So we can see that now we have a square and a difference and a minus in between. So we have a difference of 2 square. So we can express this as 2 sec squared theta minus 3 into 2 sec squared theta plus 3 d theta, all divided by 2 sec squared theta plus 3. So we had a difference of 2 squared, so the example here, so what I did with that is just the same as what we have here. So that 2 sec squared theta plus 3 will cancel out with that 2 sec squared theta plus 3, and we'll be left with the integral of 2 sec squared theta minus 3 d theta. So we have to integrate, so this 2 is a constant, so the integral of this sec squared theta is equal to tan theta, also available on the formula sheet. The integral of this 3 with respect to theta will be equal to 3 theta plus c. So our answer for question 3.6 is 2 tan theta minus 3 theta plus c. If you have any questions, you can leave them in the comment section below. And if you find these videos useful, consider subscribing, liking this video, and sharing it with your fellow mates.